Hey Algebra kids, today we're starting chapter 10. I'm super excited that chapter 9 is done. We love quadratics, and now we're moving on to exponents, or square roots. And so square roots are, you have to know your exponents with the square roots, and you've got to make sure that you know your perfect squares. Really, really easy. I'm going to go kind of fast through this video just to get everything done, but make sure you're pausing and stopping, rewatching if you need to go through things. Okay, so basically what I'm doing is I want perfect squares because whenever I do the square root of something, it's going to give me a messy decimal. The square root of 12 is going to give me a messy decimal. So I need to make sure that I've got these top numbers all memorized. Okay, so what I want to do is I want to try then to pull out a perfect square. So 12 I know goes down into two things. It goes down into the square root of 4 and the square root of 3. Well, I know the square root of 4, the perfect square root of 4 is 2. And so it just becomes 2 square root of 3. That is my exact answer. Once I do that, I can't work out any farther. The square root of 3 is going to give me a messy decimal. I don't want messy decimals. I want them to work out perfect. So here I'm going to do the square root of 9 and the square root of 3, which is going to give me 3 square root of 3 because the square root of 9 is 3. 90 is going to break down into, we're going to do 9 and 10, the square root of 9 and the square root of 10. So then that would be 3 square root of 10. Now 10 would break down into 5 and 2, and 5 and 2 is the only thing that goes into 10, and neither of those are perfect squares, so we're going to stop there. Okay, moving on. 20 breaks down into the square root of 4 and the square root of 5. Now notice how I always put the square root of a perfect square first because I know that that's going to be actually 2 square root of 5. 40 is going to break down into the square root of 4 and the square root of 10, and we already talked about the square root of 10, so we know that that one's not going to go any farther. Now 52. So 52 is not a common one that you would think of. So you might have to pull out a calculator, and I would go through and like think 52 divided by 4. That's going to work out perfect. So it'd be the square root of 4 and the square root of 13, because 4 times 13 is 52, which would give me 2 square root of 13. I know that 13 is a perfect square because it is a prime number, or not a perfect square because it's a prime number. So the only thing that goes into it is 1 and 13. All right. So then 56. 56, we've got, let's see, 56 divided by 8, so it would be 8 and 7. So I could go ahead and do that, and 8 and 7, and neither of those are perfect squares, but 4 is. So I could then do 4 and 2 and 7. And then the square root of 4 is 2. Since neither of those work, I can actually just recombine them in 14. From the very beginning, you could have probably also have done the square root of 4 and the square root of 14. That would have been a little easier and get the same answer. Okay, so 60. I want to think of perfect squares that go into it. Well, I know that possibly 4, 4 and 15. So that would be square root of 4 and the square root of 15, which would be 2 square root of 15. Moving on to 72, is going to be, I'm going to do a square root of 9 and the square root of 8. Okay, so then that's going to be the 3 square root of 8. Well, 8 can actually break down into 4 and 2. Okay, so then I have 3, and that's going to become times 2. And then square root of 2, because the 4 is the square root of 2. So then I'm going to multiply those two numbers together. That gives me 6 square root of 2. And I know you're saying, well, what just happened? Okay, so just bear with me. We're going to do more practice on that. So for 200, I'm going to do the square root of 100, because I know what that is, and the square root of 2. So that would be 10 square root of 2. I guess with 72, you probably could have done, what, 36? Could have also done the square root of 36 and the square root of 2, which would be 6 square root of 2 as well from the beginning. So there's multiple ways to get to these answers. Okay, so now the question is, what happens when I have fractions? So with fractions, we're just going to break them up into two things. We're going to simplify both the top and the bottom. So that's going to be the square root of 9 over the square root of 49. So that's just going to be 3 over 7, okay? Which makes this 1 over 9. Which makes this 6 over 11, and these work out perfect. Okay, so now when they don't, so I end up with the square root of 5 over the square root of 64. Well, I know that the square root of 64 is 8, but the square root of 5, nothing goes into that. So my answer just becomes a fraction with the square root of 5 on top. Okay, so now I've got both variables and my numbers. So you want to split those in half. So I'm going to do the square root of 9 and the square root of x. Now the square root of x we can't do anything with because it's one number, we don't know what that is. But we can do the square root of 9, which is 3. Okay, so again, I'm going to break this up into two things. I've got the square root of 16 and the square root of x, which becomes 4 square root of x. Okay, and then I've got the square root of 4, and then I've got the square root of x and the square root of y. And you're going to probably think that I'm crazy because I'm going to put these right back together, but it'll make a lot more sense later. So the square root of 4 is 2, and then these, neither of those change, so they're both going to stay underneath the square root. All right, so 75. I know 25 is an easy one that's going to go into that, so I'm just going to do the 25 and 3 because the square root of 25 is 5, square root of 3. So I want to break them down as low as I possibly can so that it's easier for me to work through. All right, moving on to 48. 6 and 8 would be in 48. Let's try, what about 16 and 3? So 16 is 4, square root of 3, and then 72. So I've got 9 and 8 would work in 72. Oh, but remember I just did that one earlier. So I'm going to do 36 and 2, so that would be 6 square root of 2. Okay, so then 32. So what's going to go into 32? Well, 16 is going to go into 32. So that would be 16 and 2. So that would be 4 square root of 2. I like these square roots of 2 as the end because that makes life a lot easier. So here with my 18, I'm going to break it up into two pieces. I'm going to do 18 and x, and then my 18 is going to break up into 9 and 2, and then x. So the 9 becomes a 3. The square root of 2 and the square root of x both stay under the square root, so those stay there. So notice anytime I'm solving something, it comes outside of the square root and the square root sign goes away because I know that the square root of 9 is 3. So it's just replacing that 3 with that square root. Okay, moving on to the end. The 8 breaks down into 4 times 2, both square roots, and then I'm going to break it into the x and the y. Okay, so this, the only thing I can work out is the 2. These 3, none of them can be worked out anymore, so it just becomes 2xy underneath my square root. Okay, so this is where it gets a little tricky. When I've got x squared, so x squared is taking x times x, right? Well, if I'm doing the square root of that, what happens is it ends up canceling. So the square root of x squared, these end up canceling each other out. So every set of 2, you can just pull out, and all I have here is my answer is x. So what I'm going to do is I'm going to do, under my n, I'm going to do n squared, and n. Okay? So I'm going to break those up for you so you can see n squared, the square root of n squared, and then the square root of n. And I always did groups of 2 until I get to 5. So I did 2, 4, 5, so that I can break those up very easy. So then those cancel. So I've got n times n, and then I've got the square root of n. Well, n times n is just n squared on the outside, and then the square root of n. And what you're going to see is I can basically divide it by 2, and then I can have whatever's left on the inside, as long as if it's an odd number. Okay, so for number 12, I'm going to do x squared and x, because that's 3, 2, and 1 is 3. And then I'm going to do y squared. Well, if I look through, these cancel. So that means x comes out front. The x squared, I have one of them that stays inside, and then this y also comes out front. So I've got this left over. Okay, so again, I know that went really fast. Remember, we're going to take some time to go over this in class together on Thursday so that we can actually spend some time really going through it. I do want to move on to part 2. So what you're doing here is we're multiplying radicals. So what we did in the last part was we divided them up, and now we're going to multiply them together. So it says, unlike addition, when taking the product, we don't care if we have like terms. When we multiply both coefficients and variables together, thus the product of 2 separate square roots is equal to the product of both square roots. You might be able to multiply the product. Okay, so what you're going to see here is A and B, you just multiply them together. So, and you might be able to simplify also at the end. So when I multiply these together, I get the square root of 6. Can I reduce that anymore? No, I cannot. 3 times 15 is 45. Okay, the square root of 45. Well, 3 and 15 are the only thing goes in 45. However, 5 and 9 also go into 45. Okay, so I can break that down into the square root of 9 and the square root of 5, which gives me 3 square root of 5. So then that's my answer there, my simplified answer. So now I've got 24 because 2 times 12 is 24. Well, I can break 24 down into numbers I can use. So like 6 and 4. So 4, square root of 4 and the square root of 6. So that would be 2 square root of 6. Okay, so 5 times 10 is 50. And then you can break 50 down into perfect squares. So that would be 25 and 2. So that would be 5 square root of 2. Again, I know I'm going super fast. Uh-oh. Take your time to go back and rewatch the video if you need to. Okay, and so here, that would be 2 times 7 is 14. I cannot break 14 down into anything other than 2 and 7, so it stays like that. 3 times 10 is 30. I could break it down into 3 and 10, 15 and 2. That's all it's going to be. 5 and 6. But neither of those are perfect squares. Is 4 going to 30 at all? Nope, that's a 7.5. So that's all I have for that number. So it's just the square root of 30. So here I'm going to get the square root of 28. I could probably do 28 divided by 4. Yep, I could do 4 and 7. So that would work out. 4 is an easy one that goes into a lot of numbers, so I would always divide by 4 if I can. So this is 15 times 5. Which is going to give me 75. Oh, that's perfect. I like 75 because it's like quarters. So that breaks down into 25 and 3. Square root of 25 is 5 square root of 3. Again, I'm so sorry that we're going super fast. I want you to take your time if you need to. Okay, so a square root times itself will always equal what's under the radical. So if I have the square root of 2 times the square root of 2, that gives me the square root of 4, which is, in fact, 2. Okay, so whenever you're taking the number times itself, it just gets rid of the radical. So this would be the square root of 49, which is just 7. This would be the square root of 25, which is just 5. So anytime you're multiplying that radical by itself, you're basically getting rid of the radical. Okay, and we're going to need that trick later once we start multiplying and dividing by bigger numbers, and you'll see what that means. Okay. So here I've got numbers on the inside and numbers on the outside. So I've got the front numbers and then I've got the square root numbers. Basically what you're going to do is you're going to multiply the two front numbers together and then you're going to multiply the square roots together. Okay, so 2 times 4 would be 8 and then the square root would be 21. Can I break 21 down in anything other than 3 and 7? That would be a negative ghostwriter. So it's just 8 square root of 21. So then 5 times 4 is 20. And then I do 8 times 2, which is the square root of 16. Well, the square root of 16 breaks down into 4. So that's going to be 20 times 4, which is 80. That makes life super nice. Now, if you actually went in on a calculator and you did 5 square root of 2 times 4 square root of 8, miraculously, you would get 80. It would not give you a messy number. So just a fun fact there. Try it out. Pause the video. Try it out. Okay, so 7 times 9 is 63, and then 8 times 3 is the square root of 24. So 24, remember, is 6 and 4 goes into that. So I've got 63, and then I've got the square root of 4 and the square root of 6. I always want to put my perfect squares first. So 63 times 2, square root of 6, and 63 times 2 gives me 126, square root of 6. Okay? And then when we're doing number 5, it would be 2 times 4, which is 8. And then I'm going to do 3 times the square root of 3 times the square root of 7 is going to be the square root of 21. 3 and 7 is the only thing that does go into 21, so I'm just going to leave it as that. All right, couple more, guys, couple more notes. So as we're moving on, we're going to distribute. And so remember, we only distribute what we need to here. So I'm going to get 3, and it's going to be square root of 6 plus 5, square root of 6 times 3 would be 18. Okay, 18 does break down into 9 and 2. So I'm going to do 3 square root of 6 plus 5, that would be the square root of 9 and the square root of 2, which would be 3 square root of 2. Well, 3 times 5 would be 15 square root of 2, and then that's going to be my answer here. Now, I'm not going to finish through all of these pages. I'm running out of time. So what we're going to do is we're going to do one more together, and then the rest, I would like you to start trying 3, 4, 5, and 6. Otherwise, we're going to talk about the rest of it tomorrow in class. So if I distribute out, I get 8 square root of 10 plus 5 square root of 30. Can I break anything down? Well, the 30 goes into, is one of those that remember that I can't break down at all. So moving on, if I could do this, I have 12. I'm going to multiply the numbers out front, so 12 square root of 6 plus